Hi guys, a very good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. And welcome once again to the summer special probability course. Yes, to upskill your level in probability and distributions, one of the very important topic for every competitive exam, be it GATE, engineering services or ISRO or NIELIT or whatever it is, a very important topic for all of these examinations. I mean, important in the sense that you expect questions from this topic on all of these examinations, okay, with a good probability, okay, with a very good probability, right? So guys, today is the turn to discuss normal distribution. In the past classes, we have discussed discrete distributions, going to binomial distribution, Poisson distribution. Then we have also learned the fundamentals of continuous random variable, that is the continuous distribution, PDF, mean, variance and different properties, okay, area under the curve and all those things. And today we take one special distribution, that is the normal distribution. Okay, so let's get started. And yes, before I start up, the again important update about the Trickopedia. Yes, the dictionary of tricks, the Trickopedia, okay, to trick the GATE examination. Okay, on your favorite BYJU'S exam prep for the ESE, NCS, every day on the channel you will get one video early in the morning. That's going to be a short crisp video, maybe 3, 4, 5 minutes, and in that one video you will get one particular trick of one particular concept. Yes, in the beginning you study the concept in detail, but later on, okay, as the time progresses, you need to speeden up. You need to learn the shortest methods of solving the question. All those shortest method and approaches, okay, will be in the Trickopedia. Okay, every particular Trickopedia video may be a 1 or 2 mark booster in your GATE examination. So attend all these videos and subscribe to the channel immediately, right? Also guys, the national scholarship test for GATE examination. Yes, take a next step towards your success in GATE examination. And if you want to avail any financial assistance, okay, you can get up to 90% scholarship by proving yourself. Yes, appear on this Sunday, that is 18 June at 12 p.m. and register. Okay, you can register now for free. All right guys, the first question, as you know, the theme of the series, as you have been following from the past few days as well. Yes, the theme is we take up a question. When required, we revise the relevant concept, but mostly we target on question and the approach. Okay, mostly we target on the question and its approach. What should be the, what is happening here? Okay, what should be the approach? Okay, so that whenever you end a particular class, you should be clear about solving all variety of questions from that particular topic. Okay, from that particular topic, right? Okay, good evening Shweta, Ruby, Sanjeev, very good evening. A random variable x has the normal distribution with a mean of 100, and with the mean of 100, a specific mean value has been given to me, and the very first important property that should strike with respect to a normal distribution is its symmetry. Okay, all conceptual and numerical based questions will be covered up in today's class. Just stay tuned. Okay, there is a normal distribution whose mean is given to you as 100. Okay, and we know that normal distribution is a bell-shaped curve, represents a bell-shaped data, and that is always symmetric about the mean value. That is always symmetric about its mean value. That is given to you as 100 here. That is given to you as 100. One of the data is given to you. What is the probability that x is between 100 to 120? 100 to 120 is alpha. Okay, so from 100 to 120, let's say this is the point 120. Okay, so symmetrically on the other side, see, this is 20 above 100. So there can be a point 20 below 100. Okay, that is known as 80. That is known as 80. Now we know that normal distribution represents a bell-shaped data which is symmetric about the mean value. Let's have a quick recollection of some important points about normal distribution. Yes, normal distribution represents a bell-shaped curve, okay, where it is symmetry, the mean is known as the symmetry point. Okay, that is the normal distribution is symmetric about the mean value. Its PDF, as we all know, is given by 1 upon sigma root 2 pi e power minus of x minus mu whole square divided by the 2 sigma square for all values of x. Okay, for all values of x, that is from minus infinity to the infinity, right? Mu, as I told you, is the mean, is the symmetry point also, and sigma square, as always, is the variance of the distribution, and PDF is again what I have written here, right? Acha, if the normal distribution has zero mean and unit variance, okay, that is also known as a standard normal random variable. A standard normal random variable is one which has zero mean and unit variance, which has zero mean and unit variance. And when I put down the zero mean and unit variance, I will be getting a function of the form, let's say it is a variable z, x is any normal random variable, z is the special normal random variable, that is the standard normal random variable with zero mean and unit variance, and its PDF will be 1 upon root 2 pi e power minus z square by 2. Now, let's suppose I want to calculate any probabilities with respect to z or maybe with respect to x. Okay. Now, probability that z is less than equal to z, I am just telling you probability z is less than small z. Okay, so less than up to what? Up to the lowest possible value, that is minus infinity. Okay, so we can say that z is from minus infinity to z. And how to find the probability when PDF is given? Probability that the random variable is between a to b, it is integral a to b of the PDF. So similarly here it is integral minus infinity to z of the given PDF of 1 upon root 2 pi e power minus z square by 2 dz. 1 upon root 2 pi e power minus z square by 2 dz. Okay, that is what the phi z is. Clear? That is what we can say phi z is equal to. Okay, now this is an integration which cannot be directly solved. There is no direct integral formula to deal with such a function, and that is why this integration is solved by the help of numerical methods. Okay, like the trapezoidal or the Simpson's rule. Okay, after calculating the value of this integral for different values of z, okay, by numerical methods, its values are recorded. Its values are already available and it is recorded in the form of tables or calculators or in Google. Okay, you can find its value in Google, you can find its value in the regular scientific calculator, not in the GATE virtual calculator, but in the Casio scientific calculator, that is the engineering calculator. Or if you have any standard mathematics book, you will find its value at the end in the form of table. Okay, the value of standard normal distribution will be given to you. Okay, that is only for standard normal distribution. What if a variable is not standard? Okay, will there be table for probability of all normal distribution? How many such normal distributions are possible? Infinite. I mean, by changing the values of mu and sigma, you can form infinite such variables. We can't make infinite records, we can't make infinite table. That is why we define a standard normal random variable. And suppose if a random variable is in general x, which may be non-standard, we need to convert it to standard. How to convert to standard? Okay, to convert it to standard, recall these properties that I have told you in the earlier class. Yesterday class also, discrete distribution class also, that if y is ax plus b linear function, then mean of y is a mean of x plus b and the variance of y is a square variance of x. That is what is already known to me. Okay, if I just use these points, guys, and just hold on for a second. Right. Okay. So if I just use this particular point and let's say x is any normal random variable having any mean mu and any variance sigma square. These are the two important parameters of normal distribution, the mean and the variance. Okay, now dear, okay, if I do a transformation, okay, if I do a transformation x minus mu by sigma, let there be a variable z which is x minus mu by sigma. Okay, everybody, one very important point, x minus mu by sigma, right? So this can be broken as 1 by sigma x minus mu by sigma, or this is like ax plus b. This is like ax plus b. Okay, what is the mean of z? Right, what is the mean of z? Right, it is a mean of x. What is the value of a? 1 by sigma into mean of x minus mu by sigma. A mean of x plus b, that is the formula we know, na? Okay, now what is the mean of x? That is mu. X का mean तो mu ही है, तो 1 upon sigma mu minus mu by sigma, eventually 0. So this random variable will have 0 mean. What about the variance? Guys, what about the variance of this distribution? Variance is given by a square into variance of x. A square into variance of x, right? So that is 1 by sigma whole square, yeah, 1 by sigma square into variance of x, that is sigma square. So sigma square got cancelled, this is equal to 1. So what is variance of z? That is equal to 1, unit variance. So by applying the transformation x minus mu by sigma, I can say that the mean of z is 0 and the variance is 1, and hence by these two parameters I can say that z is nothing but a standard normal random variable. Okay, z is a standard normal random variable. So by applying the transformation x minus mu by sigma, okay, we get a random variable, we get a normal random variable which is standard, a very important point, okay, we get a normal random variable which is standard. We will come back to the first question. Let us revise 2 or 3 more important points. Okay, so this is already mentioned, one of the very important point about, okay, and you will see that in competitive exam there can be some questions based only on symmetry. There can be some questions based only on symmetry. And because a normal distribution is symmetric about the mean, okay, because it is symmetric about the mean, so what can you conclude here, right? This much of the area and this much of the area should be same because of symmetry. Okay, the area before mean and area after mean is same. And what is the total area? So total area under any PDF, be it normal or anything, the total area under any PDF is always unity. Right. So if the symmetry line is dividing this curve into two equal areas, so each area should be 1 by 2. Each area should be 1 by 2. Right. Each of the area is 1 by 2. Okay. So area after mu or area up to the mu is 1 by 2, and we know that in continuous random variable, probability of a range can also be calculated as area of the range. Okay. So area x greater than mu also means probability x greater than mu. Okay. And now you can think like this also, total probability is always 1. So probability after the mu and probability up to the mu is equal, and that is equal to 1 by 2 because of symmetry. Okay, because of symmetry, right? What is probability after mu? Integral mu to infinity. What is probability up to mu? Integral minus infinity to mu. So these two integrals should be equal and equal to 1 by 2 each, right? If x is a normal random variable, okay, then y, any linear combination, is also a normal random variable. Okay. So we're focusing on question, no derivation required, but some important points you can note down, right? If x is normal, y is equal to ax plus b, a linear function is also normal with the mean and variance written. You can anyways find the mean and variance because you know the mean and variance of ax plus b. Okay, right? Then this is already, I told you, this is one of the very important point already. ये मैंने जरूर आपको explain कर दिया that if x is normal random variable having any mean mu and variance sigma square, then z is equal to x minus mu by sigma becomes standard normal random variable having zero mean and unit variance, as we just discussed under this point. X minus mu by sigma makes it a standard normal distribution. Makes it a standard normal distribution. ठीक है? अच्छा, if x1 and x2 are two independent normal random variable, if x1 and x2 are two independent normal random variable, then y equal to a1 x1 plus a2 x2 is also a normal random variable. Okay, ठीक है? Addition of two normal independent random variable is also normal random variable. Okay, why I am writing this? Because sometimes with respect to normal distribution, one marker important factual or property based question also comes up. So you can note down this also. There has been a question based on this in GATE. So if you have two independent normal random variable, when you add them or when you subtract them, when you make any combination like a1 x1 plus a2 x2, that will also be a normal random variable. Okay, that will also be a normal random variable with the given mean and variance. Right, with the given mean and variance. Okay, now some of the very important key points. Directly lots of time you will feel the questions coming on it. Directly lots of time you will feel question coming up on it. Okay, we know that any normal distribution is symmetric about the mean. When we try to find a value of any normal random variable within 1 sigma about the mean, sigma is standard deviation, within 1 standard deviation. 1 standard deviation means it can be sigma here also, sigma here also. That means mu minus sigma to mu plus sigma. So if you are searching a random variable from mu minus sigma to mu plus sigma, from mu minus sigma to mu plus sigma, okay, the probability is always, whatever may be the value of mu and sigma, the probability is always 68% or 0.68. 0.6826 to be precise. Again, derivation right now not required. Okay, earlier back sometime in YouTube when I was taking the detailed theory session, there I have derived these points, but right now not required. Okay, this is mostly to upskill your problem level, and you will upskill in your problem level. That's what I ensure, don't worry. Follow the session, all variety of problem you should be able to solve. Derivations and all, if you want, you can find my old videos available on the same channel. Okay. So the probability to search the normal random variable within 1 sigma about the mean is always 68%. That is always 68%. Okay, so approximately 68% of the values are located within 1 sigma. Okay, the precise value, as I told you, is 0.6826. Similarly, if you find a probability that random variable is in the range of 2 sigma, that is mu minus 2 sigma, mu plus 2 sigma, 2 sigma about the mean, it will be 95%. It will be approximately 95%, 0.9544 if you want the accurate value, 0.9544. The probability to find a random variable within 3 sigma distance about the mean. Mu minus 3 sigma up to mu plus 3 sigma. This is how much, guys? This is 99.7, which is just like almost 100. That means almost, I can say, almost all of the values are within the 3 sigma distance from the mean. 3 sigma distance from the mean. Okay, 0.997 or 99.7 is the probability of finding the variable, okay, within the range mu minus 3 sigma to mu plus 3 sigma. Mu minus 3 sigma to the mu plus 3 sigma. Clear everybody? Yes sir, clear. Okay, that is what it is, clear to us. Chalo, done. Okay, that is what it is, done. Now let's go back to the problem and let's take up some more problem. This was the first of the problem. This is simply solved by the concept of symmetry. This one can be simply solved by the concept of symmetry. Sir, how? Okay, they have given probability from 100 to 120. Probability from the 100 to 120, that is the probability of this portion, okay, is alpha. Okay, the probability of this portion is alpha, right? What is the probability? X is less than 80. Okay, they are asking the probability for this particular region then. What is the probability for this particular portion? So guys, apply a very simple logic. What is the probability up to the mean? What is the probability up to the mean? It is 50%. Okay, 0.5, 50% of 0.5. What is the probability of this portion? See, 100 to 120 or 80 to 100. Okay, 100 to 120, 20 above 100. Okay, this is 20 below 100, and because of symmetry, okay, the probability of this portion will also be alpha. This will also be alpha by symmetry. It's a symmetry based question. You don't have to solve anything much. Okay, so what is the answer then? What is the answer? This particular probability. Okay, up to the mean, up to 100, 50%, 0.5. Okay, out of this I need to subtract this portion, that is alpha. So answer is 0.5 minus alpha. Okay, or it is 1 by 2 minus alpha. This can be written as 1 minus 2 alpha upon 2. 1 minus 2 alpha upon 2. Correct answer is C. The correct answer is C. 1 minus 2 alpha by 2. Got this? It's a concept. It's a question based on symmetry concept. Okay, if the probability from 100 to 120, because 100 is the symmetry line, mean is 100. From 100 to 120 is whatever the probability. From 100 to 80. Okay, because same distance, right? This is 20 ahead, this is 20 below. ठीक है जी, ठीक है जी. Moving ahead to the next question here. Moving ahead to the next question here. Some important points are discussed. Yeah, next question. Again, a fundamental question. Some questions can be really fundamental, and then some questions can be a little bit tricky as well. A normal random variable has the following probability density function, has the following PDF. Fx equal to 1 upon root 8 pi e power minus x minus 1 whole square by 8. What is integral 1 to infinity fx dx? Okay, ठीक है. Thank you, GN. Okay, what is integral 1 to infinity fx dx? Okay, integral 1. What is 1 actually? X minus mu whole square. So 1 is the mu point. 1 is actually the mu point. Okay, so integral 1 to infinity is like integral mu to infinity. Integral mu to infinity fx dx. Integral mu to infinity fx dx. Right, and as I already told you, integration up to the mean or integration after the mean, okay, is 50%. Is 50%, 1 by 2. So the answer is very simple, 1 by 2. Very logical, very simple question. It is 1 by 2. Again, symmetry point is utilized. Okay, that this is the probability after the mean. Probability up to mean and probability after mean, both are equal and equal to 1 by 2. 50-50% each. 50-50% each. Okay. Next question. Again, by symmetry you can solve this question. It's a very logical question. The annual precipitation data of a city is normally distributed with mean and standard deviation as 1000 mm and 200 mm respectively. What is the probability that annual precipitation will be more than 1200 mm? What is the probability that annual precipitation will be more than 1200 mm? Will be more than 1200 mm. It is the annual precipitation data of a city is normally distributed with mean 100 with mean and 1000, standard deviation 200. What is the probability that precipitation will be more than 1200? We can calculate also this value, but not required. Okay, we can calculate also, but not required. Okay, how to solve it up then? Okay, more than 1200. What is the probability that the annual precipitation will be more than 1200 when the mean given to you is 1000? just drawing the bell shaped curve again. This is 1000 mean. They are asking with respect to 1200. Okay, they are not asking the accurate value, they are just asking what is the range, less than 50, 50, 75, 100. Okay, so they are asking the probability of this portion. Annual precipitation more than 1200. More than 1200, so definitely, okay, the area from 1000 to infinity, okay, this much of the area is 0.5, this much of the probability 0.5, okay, or this is 0.5 means 50%. So whatever is this probability, it is going to be less than 50%. Correct answer, it is going to be less than 50%. Correct answer A. Okay, I told you, it's a logical question as of now, concept based question. The correct answer is A. It is less than 50%. It is less than 50%. It is less than 50%. Okay. Achha, can we find out its accurate value? Right now the question is solved. Can I find out its accurate value? Yes, we can. We can find out its accurate value also. Yes, we can find out its accurate value without any other given data. Without any other given data. Not required as per the given options, okay, but just in general you must know. Sometimes, by chance you get a NAT question without any option. Okay, this is 1000 and this is the point 1200. Okay, right, now this is mu, so 1200 is actually mu plus sigma. Okay, because sigma is 200. That is why you can find here. Okay, so let me also define a point 800 which will be mu minus sigma. Okay, and we need the probability of this portion. Okay, now guys, how much is the probability of this portion? That is a standard result. The probability from mu minus sigma to mu plus sigma, okay, it is 68% approximately. It is 68%. That is a known value. That is a known value. So what is the probability of this portion? For this much of the portion, see, total is 100%. Okay, minus 68. But if I do 100 minus 68, I get probability of this side as well as probability of this portion. That is total 32%. But symmetry is there. So probability after 1200 and probability before 800 is equal. Na? It is equal because of the symmetry. Okay, because of the symmetry. So the answer of the right hand side, total whatever it is, divide by 2. So 32 by 2, 16%. That is the 32 by 2 and that is known as the 16%. So if you want the accurate answer, it is 16%. As per the given data, it was not required because options helped you. But in general, you can find it out. It is 16% actually. It is 16% actually, right? Chalo, next question. Now, whenever you are not able to solve by symmetry, or whenever sigma 2 sigma rule doesn't apply, okay, there will be some values, okay, that must be given. As I told you, okay, the values of standard normal distribution are recorded in tables and calculators, and in GATE exam you don't have the Casio calculator, you don't have any book for table. So if any value is required by chance, they will be given. Otherwise the question will be on symmetry or the sigma rules, 1 sigma, 2 sigma and 3 sigma calculation. If x is a normal variate with mean 30 and standard deviation 5, what is the probability 26 less than equal to x less than equal to 34? 26 less than equal to x less than equal to 34. 26 less than equal to x less than equal to 24. First of all, x is a normal random variable which is having mean 5, mean 30 and standard deviation 5. It is non-standard. Always the first rule, as I told you, convert into standard. Convert into standard. And to convert into standard, what is the rule? X minus mu. Okay, so 26 minus mu. Actually the mu is 30. Okay, so subtracting mu on all sides, 26 minus 30 less than equal to x minus mu, less than equal to 34 minus 30. But not only x minus mu, divide by sigma. So on all the sides, divide by sigma. What is the sigma? It is 5. What is a 5? And then guys, what is x minus mu by sigma? X minus mu by sigma is known as z. It is known as the z. So this question now becomes probability minus 4 by 5, that is minus 0.8 less than equal to z less than equal to 0.8. Okay, where z is a standard normal random variable, and because z is standard, okay, by standard का mean क्या होता है? Standard का mean होता है 0. If I want to talk about the distribution of z, Okay, Z is standard and hence it has 0 mean and its symmetry line is 0 and hence its symmetry line is 0. Okay, now you are looking for the answer from minus 0.8 to plus 0.8. Minus 0.8 to plus 0.8. What is this much of the area? Dear, what is this much of the area? अच्छा, ये नहीं पता मुझे, but what I have given area Z greater than 0.8. Area Z greater than 0.8 is 2118 and I want complete this much of the area ना, ठीक है, तो ये निकाल लेंगे. How much is this much of the area? See, area for this portion actually is 0.2118, right? So similarly area for this portion is also 0.2118. Okay, so because of symmetry, जो 0.8 के आगे है वो minus 0.8 के पहले, so that is also 0.2118 and total area is 1. Total area is 1. Okay, 1 minus, when you do this area, twice of 0.2118, you will get the remaining area. You will get your desired area. Okay, you will get your desired area. Okay, so let me complete the calculation. It should be 0.5764. It should be the 0.5764 dear. 0.5764. Correct answer is C. 0.5764. Okay. 0.5764. Okay. 0.5764. Done hai? Chalo. Next question dear. Next question. Alright, the today's YouTube community post, as you know, for these daily videos that you're getting on probability and distribution, okay, one particular relevant question is posted in YouTube community, okay, early in the day, okay. So if you are subscribed to the channel, you will be getting the YouTube community post as well. Okay, this was the YouTube community quiz question. YouTube community quiz question. Okay, how many have answered? This was posted late today, but still let's see how many have answered it. How many have answered it? Let's have a look into it. All right. Around 60 students have answered and 86% correct. Okay, around 60 students have answered and 86% have got the correct answer. That is R will be less than S. 86%. Great to know that. So let's have a look into this. A continuous random variable X is normally distributed with mean 6 and standard deviation 2. Consider the following probabilities. Okay, R and S. Which of the following is correct? X is a normal distributed random variable where mean is 6 and sigma is 2. Okay, the mean is 6 and sigma is 2. Okay, the mean is equal to 6 and sigma equal to 2. Maybe we don't require the accurate calculation. Okay, but yeah, we can judge out the answer. Accurate bhi kar sakte hain, but that is what is not going to be required. Let me draw the bell-shaped curve first of all. Okay, the mean is 6. Okay. In the first case, I am looking for the probability R 4 less than X less than 10. 4 to 10. 4 to 10. This is the probability I am looking for. Okay, from the 4 up to the 10. From 4 up to the 10. Okay, from 4 up to the 10. Okay, in the next case, okay, I have the same normal random variable. Mean value 6, but next I'm looking for the probability. That X is between 0 to 8. This whole particular portion. Okay, which should be more, which should be less. Okay, this is the probability. I think they have mentioned the first one as R. Okay, isko R bol denge. What is this? This is known as R. R is the probability that 4 is less than X is less than 10. Okay, and S is the probability that 0 is less than X is less than 8. Now what is common? Pura solve nahi karna hai. You have to solve it again by concept and logic. Okay, what is common here is the probability from 4 to 8. From 4 to 8. Okay. Okay, the probability from 4 to 8 is common. That is going to be how much? Okay, now what is 4 and what is 8? Okay, 6 means the mu. Okay, 6 is the mu point. So this is mu plus sigma because sigma is 2. Dhyan dena. In the given question, sigma is actually 2. In the given question, sigma is actually 2. Right. So this is mu plus sigma and this is known as mu minus sigma. Okay, this is what is the range. Okay, mu minus sigma and mu plus sigma. Right. So how much is this value? This is 68%. Similarly, here also, this is 68%. Now, probability from 8 to 10. Probability from 8 to 10 will be how much? Okay. And probability from 2 to 4 will be how much? ठीक है, इसको भी अगर मैंने break किया, let me break it into actually 3 different parts. Let me actually break it into 3 different parts. 0 less than x less than 2. Okay, probability 2 less than x less than 4. Okay, plus this one. Okay, so what is the probability between 8 to 10? Okay, between 8 to 10. 8 to 10. Same should be the probability between 4 to 2 because of symmetry again. Because of symmetry. Okay, so let us say this probability is some probability P. Okay, right. So this is a question mark, I don't know, but the P will again come up here. Na? So 68 plus P, there it is 68 plus P plus something. 68 plus P plus something. We can find out that something. We can find out that something, but not required. But not required. What is the correct conclusion is R is less than S. They want the comparison. They don't want the value. Na? So why you should spend time in calculating the value? This is lesser than the other one. R is less than S. Correct answer is B. Correct answer is B. R is less than S. You can find the accurate value like I have shown you for the precipitation question. Like I have shown you for the precipitation question. Here also you can find the accurate value. That's not a big deal, right? You can find that accurate value anyways, right? Okay. Chalo, done. Okay. Let's move ahead then. Okay. Let's move ahead to another important concept related, okay, related with this distribution. Look into this. A coin is tossed 180 times. A coin is tossed 180 times. A coin dice. A die is tossed 180 times. If the probability R of 6 turning up at least 35 times is calculated through normal distribution. Now, this dice or coin problem. In a die, 6 may come up, may not come up. This looks like what type of distribution? Okay, this looks like whenever I throw a single die, whenever I talk about the toss of a single die, right, it may give you a 6, right? It may give you a 6 or it may give you not a 6. These are the two possible outcomes. Actually 6, but I'll categorize into 2. Okay. The question is concerned with 6. So let's say if you get the 6, that is a success. If you don't get a 6, that is a failure. So problem is categorized into success and failure, I can say. Okay, the single dice can have 6, cannot have a 6. Okay. Now, how many trials are done? Okay, 180 times the die is tossed. So n is equal to 180 tosses are made. Okay, 180 tosses are made, and as always, let k is equal to number of success. And number of success here means number of 6s. Kitni bar 6 aaya, right? And what you need? Probability of 6 turning up at least 35 times. Okay, what we need is, what is the probability that this k is greater than equal to, let's call it in terms of random variable only. Let x be the number of successes and we want x is greater than equal to 35. At least 35, more than this. Now, in a particular event, when there are only two possible outcomes, success or failure, like head or tail, like 6 or not a 6, that can be classified as, that single experiment is classified as Bernoulli's trial. Repeated and independent Bernoulli's trial comes under the binomial distribution. Okay, so this actually is a binomial question. This actual is a binomial question. Okay, this actual is a binomial question, and as per the binomial question, as per the binomial, probability that x takes the value k can be calculated by the formula nck p power k q power n minus k, q raised to the power n minus k. So what is the probability that x is not only one value, x is greater than equal to 35? Now look into the complexity of the calculation. It will become 180c35, not only 135, 180ck, it will be 35 and all the values above 35. Okay, 180c35 p. Acha, what is the p? What is the p? Okay, p is the probability of success in a single trial. Okay, and in a single trial, getting a 6 has the probability 1 by 6, right? So yeah, p value 1 by 6 raised to the power k. So q value will be 5 by 6, 1 minus p raised to the power n minus k, 180 minus k. For how many k's? For all the values k that are greater than 35, and maximum number of 6's can be 180. Can you solve this calculation? Can you solve this calculation? If it was a single calculation, still we can take the help of calculator. Suppose if it was only k35 or k36, but can you actually practically solve this calculation? Okay, can you practically solve this calculation? It is practically very lengthy. It is practically very lengthy, nearly impossible. It's practically impossible to deal with such a calculation. Okay. There was a development, again derivation not required. I have derived even this point also in my earlier YouTube videos, the detailed theory concept videos. Okay. But right now I will tell you the concept and the conclusion as stated back in 1733 AD by Abraham de Moivre. Okay. That if x is a binomial random variable with the parameters n and p, and when you have large values of n, okay, when you have large values of n, okay, the x can be approximated as, okay, that x binomial random variable can be approximated as normal random variable having the mean what you discussed in binomial n into p, and having the variance np1 minus p. This is nothing but npq, the variance of binomial. Mean and variance will remain same because that same distribution binomial is approximated by normal. Even if they don't say in the question, okay, the probability of 6 turning up is calculated through normal. Even if they don't say, you are not left with any other choice. Because if they don't say also, you try to solve and you come to a nearly impossible calculation. You come to a nearly impossible calculation. Okay, so what is the logic I will apply? That x is equal to 180 trials, which is large enough, and sorry, not x, number of trials is large enough, and x is going to be approximated to normal distribution having mean mu and variance sigma square, right? What is the mu here? Mu is equal to n into p. N is 180, p is 1 by 6, so that becomes 30, right? The sigma square is given by the formula npq, so that is 180 into 1 by 6 into q, which is 5 by 6. So this was already 30 by 6, 5 5s are 25. This is 25. Okay, so sigma will be 5. Okay, so I can now say that in front of you, now you will be having x, which can be approximated by not binomial but by normal distribution, having the mean mu as 30 and having the variance sigma square equal to 35. And your question is, what is the probability that x is greater than equal to 35? Question to yahi hai na? Question is probability of getting more than 35, at least 35 6's. What is the probability x greater than equal to say 35? Guys, how do you solve what is the probability x greater than equal to 35? Acha, first of all, x, is it standard? When you come to normal, it is very important to feel that whether it is standard or non-standard. Normal. It is a non-standard normal random variable. It is a non-standard normal random variable. Okay, and hence I can call it as probability x minus mu. Okay, I'll just subtract mu divide by sigma. This should be greater than equal to 35 minus mu. Mu is actually 30. and sigma square is 25, so sigma should be the 5. And now x minus mu by sigma is known as z, and z should be greater than equal to 5 by 5, that is 1. So what do you want? You want the probability z greater than equal to 1. You want the probability z greater than equal to 1, and area between z equal to 0 and 1 is given. What is the probability z greater than equal to 1, dear? What is the probability z greater than equal to 1? And you are talking about standard distribution whose mean is 0. Standard distribution whose mean is 0. So it is symmetric about 0, right? Suppose this is 1. Okay, what do you want? Okay, you want the probability of this portion. Okay, the probability, the area in the data given, the area between 0 to 1 is 0.35 approximately. Okay, the area 0 less than z less than 1 is 0.35. Okay, so what is the area for z greater than 1? Okay, so how much is half of the area? This is 0.5. Area after the mean is 0.5. Okay, so this is going to be 0.5, half of the area, minus this much of the area, that is 0.35, that is 0.35, and the answer for this probability is 0.15. 0.15. Okay, such indirect and good question can be there in GATE 2 marks. Okay, now if you have noticed, this is MSQ question. Okay, mean is 30, yes. So what are the correct answers here? Mean is equal to 30, yes. The standard deviation is 25, no. Okay, standard deviation, sigma square, variance was 25, so standard deviation is sigma, which is 5. So don't be confused, and hurry buddy, don't mark 25, right? The value of R is the probability of 6 turning up at least 35 times, that is 0.15. Okay, so it is not 0.85. So the correct answer for this multiple select question is A and C. The correct answer for the multiple select question is A and C. It is A and C. Yes, wrestling. Whenever it is non-standard, always you have to see. If it is non-standard, there are 2-3 ways. Either the question will be only on symmetry, or it will be on the sigma rule, like we have solved 1 sigma, 2 sigma, 3 sigma. Or if it is not on sigma or symmetry, then there will be some area given, but that area is always under the normal curve. Z means a standard normal curve. So you have to convert it to standard. You have to convert it to standard. Okay. ठीक है जी. You have to convert it to the standard anyhow. Right. Chalo. Let me give you 2 homeworks again for today's class. As always, I am giving you the homework. You have to comment your correct answers. You have to comment whatever you solve. Take a deep breath, solve it in the night, solve it in the morning, whenever you feel like, but solve both the homeworks. Homework number 1, this is very fundamental. You have to compare what is the PDF of normal distribution, and based on that, you have to find the value of k. It's fundamental. Okay. Homework number 1. Homework number 2. Let x be a normal random variable, okay, having normal distribution with mean 1 and variance 4. Let y is another normal random variable with mean -1 and variance is unknown. Okay, now they are given. Probability x less than -1 is probability y greater than 2. Some probability results are given. What is the standard deviation? Sigma of y. Okay, what is the standard deviation or the sigma of the y? This is the homework number 2. Also, you will get the PDF in the Telegram group, and that PDF is going to be password protected. Let us keep the very simple password. Normal distribution ka class hai. Randomly I am giving you the simple password, that is normal, NORMAL. That's it. The password is so normal. Okay, everything in small, NORMAL. The PDF will be in my Telegram group. Okay, the PDF will be in my Telegram group. Also guys, one very important point, okay, now for you is that, yes, if you have really prepared and if you want to compete with all, okay, if you want to show that yes, you have really prepared, so there is a mega interactive quiz on discrete random variables that is coming up on Monday. That is coming up on the Monday on the BYJU'S exam prep app. On the BYJU'S exam prep app at 5 p.m. time. At the 5 p.m. Monday 5 p.m. Interactive quiz on discrete random variable. Okay, including binomial, Poisson, everything. Okay, then Tuesday continuous random variable again on the app. Okay, that is going to be Tuesday then at the same time 5 p.m. Tuesday at the same time 5 p.m. Okay, where you are going to get the questions on continuous random variable, including normal, exponential, whatever you have studied. Okay, you'll be getting a quiz on that. And the very important part is, okay, the toppers of both the quizzes, the good performers of both the quizzes will be analyzed. Okay, and based on the cumulative result, there will be a special reward for the topper from our side. there will be a special reward. Okay, so that is a motivation. Prepare this weekend. Okay, one of the very important core topic, important for every exam. Again, I say, whether it is ISRO, NIELIT, ESE, GATE, or any other competitive exam, very likely that you get a question, at least one question from probability and distribution. Given you a good idea in this particular classes. Weekend prepare. Monday, Tuesday, let's meet on the app. Okay, so if you don't have the app, just go to the Google Play Store and download the app right now. Okay, and get a chance to win exciting rewards based on your good performance. Okay, this is what it is. That's it for this session from my side. Bye bye. See you on Monday 5 p.m. for the quiz. Monday 5 p.m. with the quiz session on the app. Bye bye. Thank you. Stay safe and take care of yourself.